We are going to talk a little bit about codes now in a bigger, not so focused on the specifics of the California code that Kyle was looking for last night, but really stepping back a little bit, taking a look more broadly at how codes are developed, their role, the different parts that come into play, and sort of what the action has been on the codes front for CEA facilities. So we have a great, stellar panel here with lots of experience. We're going to hear from Keith Coursin of Desert Aire. He's going to talk to us a little bit about some of the various industry-led codes and standards affecting the industry and the equipment that's being used. We'll hear from Alexi Miller with the New Buildings Institute, who's been doing work on codes, the national model codes, as well as input to other codes across the country. And then from Kyle Booth with a little bit more on what they're looking at for California and the Title 24 process. So with no further ado, I'll bring up Keith and we can hear about the acronym soup.
Good afternoon, everyone. So I'll focus on the HVAC standards activity and try to put a little bit of a bow over the acronyms and all the different standards that are out there. And so if we look at it from a manufacturer's point of view, really being driven by two different organizations. The first one is ASHRAE, which is the trade association for all the air conditioning and heating and ventilating companies, and then AHAM, which is more the appliance. And the reason why these two become important is for most of the air conditioning and larger dehumidification systems being used, they're the AHRI one, but the portable dehumidifiers fall under the jurisdiction of the AHAM ratings. And so we've got to make sure that we compensate and understand that there's two different rating positions. Then there's the professional societies that we've already heard on the ASHRAE and the ASABE, which we actually heard from Nadia just before, and I'll just kind of put a little bit of explanation point on top of it. Within AHRI, there is no plant type of standard, and everybody starts referring back to, I have an air conditioner, I want an air conditioning load, and so that would be the 340, 360. But we don't have just an air conditioning load. We also have a dehumidification load. And guess what? We could look at the pool one and look at standard 910 and get a moisture removal efficiency standard of pounds per hour of condensate with a kilowatt input. But that really doesn't apply because the temperatures and some of the other elements aren't consistent. And then there's standard 920, which gets us into the dedicated outside air systems. And that's a very complicated standard because it's trying to handle all the weather climatic conditions that represented across really North America. And it actually rates at 4 different conditions in the cooling dehumidification mode and 2 different conditions in the heating mode. And so when you talk about this multiple standard, multiple parameter type system, it gets a very complicated one. And we've just ended up our conversation after 10 years of trying to develop this code and have finally got the Department of Energy to sign off on it. You're going to be hearing more about that particular code if you're in the HVAC industry finally here after 10 years of work. And I bring up the 10 years of work because none of these happen overnight. There is a lot of work in developing the standards as we go forward. So the AHAM actually has the 7008 2018 was the last code cycle for it. It's under the appliance. The interesting thing about this particular code is all the units being tested don't have any ductwork. So they're what we call freestanding. They're just put in the space and they blow out. So when you look at other systems that have to go through ductwork, it cannot apply to the AHAM standard because the blowers and the energy costs that they're doing. And one of the things that, one of the things that we need to understand and the difference with that one as was just being talked a little bit earlier by Nadia was the amount of ductwork and filters and other things that you put on system equipment drives up the requirement for the load. When we look at that AHAM standard, the fan has no static pressure to go against, so the rating is much lower. Now they're using a rating here in SI units at 2.7 liters per kilowatt hour, and you could translate that one over into pounds an hour, but the problem is there's no ductwork here. How are we going to apply the two standards into one common platform as we go forward? Within ASHRAE, we've got two different committees that are trying to talk about it. 2.2 is the Plant and Animal Committee, which has just really taken on the cannabis side of it. And this is a very, very recent event. They've only actually met twice to have this conversation. At the trade show in Orlando this past February, they had standing room only at two different events talking about this particular standard. So there's a lot of interest in it, a lot of people coming together. The other one is the large building segment that kind of owns a little bit of the related one, and so these two have to work together. So they're both trying to write a handbook standard to start to get preliminary information out there of how you have to size the HVAC equipment in this new industry. And so it's going to provide the guidance to the engineering community that are working with all the other people in this area. We're also looking at getting some research money put together and talk about the evapotranspiration rate, which is the critical aspect to sizing the HVAC equipment. Lighting load is one, but because of the cooling effect of it, we have to know how much is being transpired. Otherwise, we can't calculate the load. You can read all you want. There isn't a single documented research paper that's going to say for cannabis, this is the type of rate that you have. And we've got to come to that conclusion if we want right-sized equipment. The ASABE is also working on it, and they've got two different standards that are involved. The first one is in the HVAC side of it, and they're kind of looking at it from all the same elements that ASHRAE would look at it, but they're trying to do it. And we've got to make sure that we stay in concert with both organizations, and so they are talking. They have already published the S642, which is the recommended standard for the LED light type system. And so really what I'm saying right now, there is absolutely nothing out there to define a standard for the HVAC units. It doesn't exist. And if you were at the code conversation last night with the Title 24 people, we just have to use some loose verbiage in these early days because there's nothing we can reference as it goes forward. And so with that, I guess it gives us a chance to kind of organize our thoughts and get going. At the AHRI spring meeting, we're actually going to be bringing it forward to look at a development of a standard. And here's where my request is going to come back to the rest of the people that were all in this room today, is that we have to come back and come up with a rating standard, which means I have to have a temperature, I have to have an RH. And is a single point going to be acceptable to this industry? Do we need multiple points that get weighted? And so these are the type of decisions that we need to come to feed the systems as we work on this standard. And I can already tell you that as it goes, we get federally regulated. The Department of Energy is then going to take over the standard. They've done it every standard that we've done at AHRI, and it matters to what's going to go on. I'm going to switch over because there were some conversations the other day on this whole refrigerant transition. What I can tell you is that the HVAC industry is absolutely committed to going to proper GWP, low GWP rating refrigerants. It is moving forward whether the federal government goes that way or not. Now we know all the states are starting to do their own little thing along with it, but we cannot move faster than the research allows us to look at it. And the leading candidates going for the large bulk of HVAC equipment will contain flammable elements. And all the building safety code people have to sign off on this. California was a prime example where one group was not allowing it, actually disallowing it. The other group reporting to the governor was promoting it. It gets very difficult to be able to put a piece of equipment in where two different people are saying you can or you can't. So this is going forward. You're not going to see anything really come into the industry until 2023 at the absolute earliest. My gut feel is it's going to be 2024 or 2025 that the low GWP refrigerants are going to finally get through all the design and research to become part of the platform. So the good news is we're going to get there. The bad news, we're not going to get there for a couple more years. Alexi?
Okay, I'm going to shift gears just a little, and I'm going to bring it from the standards, which are referred to in codes, up to the level of codes, and I'm going to go as a bit of a broad brush here. I'm looking in large part at model codes, at codes that maybe transcend more than one jurisdiction because they're adopted by several different jurisdictions. And NBI has been involved for some years in the development of national model codes. A little bit of background. I'm not going to get too deep into anything because I have, 8 minutes here. But a little bit of background on why we are even talking about building energy codes in this context. According to the DOE, they say energy codes save building owners about $5 billion a year in energy cost, and that's per year. Obviously, this is quite a bit more over the lifetime of a building. So they say 2010 to 2040, in that 30-year span, we're looking at $126 billion with a B of energy cost savings to building owners because we have codes in place, and something like 245 coal plants worth of carbon dioxide emissions avoided. It is critical that we think about when we want to do this efficiency. It's a lot easier to do these kinds of projects when you build the building than it is to go try to retrofit this stuff in later. So the idea with an energy code is build it pretty good the first time. It sets the floor. That is a form of quality assurance for the people who are going to be using that building and the occupants of that building, whether they be plants or humans. So we want to have codes that achieve these kinds of goals, and we're pretty good at it, reasonably, broadly speaking. We're pretty good at it for buildings intended for humans. It's been a little bit of a square peg round hole situation trying to adapt these human-centric codes to plant-centric buildings and occupancies. The way building energy codes work, in the briefest nutshell, it sets the minimum efficiency requirement for a building, something that triggers code, right? And it defines, what I like to say is a code defines the worst possible building you can legally build. You got to do at least this much, and then on from there. And as a subset, the energy code is one of the several building energy codes, or building codes, sorry, you got lighting, you got energy, you got structural, you got fire, you got water, plumbing. Those are coming from national model codes. So there's this organization, the International Code Council, that, for example, one of the things I do a lot is work with the development of the International Energy Conservation Code, IECC, which comes under the ICC's ambit broadly. And a jurisdiction, Colorado, not California, Colorado, Oregon, everyone but California, basically says, we'll take the 2018 version of the International Energy Conservation Code. We'll take the 2015 version. We'll take the 2021 version. And then they make some amendments. They change things here and there, sometimes a lot, sometimes just a little. But they have this common framework that they're starting from. So one thing we have focused on over the years is moving that national model code forward so that as jurisdictions adopt, they have a better framework and we're all dealing with something reasonably consistent across the marketplace. Now, in indoor ag, with cannabis specifically, you also have licensing requirements. And some jurisdictions have said, well, we're not going to do this thing during the code, through the code. Maybe this doesn't really fall under energy code, but we can do it in a licensing requirement scenario. So now you have things you got to do with to meet code that can vary. And maybe there are also some of the elements that used to be in an energy code or could potentially be, but they're actually part of your license. Very briefly. The idea with national model codes is to provide a consistent framework, but of course, every state and lots of jurisdictions sub-state are in a different place with the adoption. So there's everything. It's probably pretty hard to read those captions down there, but that's everything from ASHRAE 90.1 2007 all the way up to 2013, and of course there are more versions coming out. It's a 3-year cycle going through here. And then a couple of states, especially Arizona and Colorado pretty relevant in this market, have a lot of local adoptions. So NBI, for example, helped Boulder develop their energy code. For the last several years, we've been doing that. So it's a consistent framework, but it's in different places in different jurisdictions around the country. So I'm going to talk a little bit about what is in this broad national model code framework. And I'm going to start with lighting because that's where we've spent some effort. NBI was successful in moving through a proposal for the 2021 IECC, the model code that jurisdictions can choose to adopt, and eventually many of them will, to say not less than 95% of the luminaires, the light fixtures used for plant growth and maintenance, shall be at least as efficient as 1.6 micromoles per joule, rated in accordance with the ASABI standard. ASABI actually has 3 different standards dealing with this. So you have to have a proper thing to refer to here. Thank you, ASABI. They put together a good standard that's something you can reference in a model code. So this was approved by the voters, which are cities, states, building department officials, et cetera, for inclusion in the 2021 National Model Code. It's going to be a few years before this filters down. But what this does is this gives a common framework, which, as we know, isn't always exactly the same thing. And Kyle will talk about that a little bit, about how it's not always going exactly this way. But there is this common framework and a baseline, right? You can still do double-ended HPS. That's about 1.7 micromoles per joule, but probably not single-ended and not fluorescent. So you must be at least this good to play. It also gives someone like someone running, say, a utility program, a way to say, well, here's a reasonable baseline. Maybe if you get a product that's on the qualified products list from the Design Lights Consortium, here's the difference between how good that one is and where the code is. So, sets the floor, puts us all on a common understanding and uses this metric. Let's talk about HVAC. How about where are national model codes in HVAC and dehumidification? What do we have in the model codes? Not much. Nothing there yet. That's not to say this topic is never represented in codes, and it's definitely not to say that codes are not relevant in terms of HVAC systems going into indoor ag or indoor horticulture facilities, because you do have to pay attention to codes in terms of HVAC when you put a facility together, design a system, all that stuff. It's not really in the national model codes, but it is a relevant concern. So why is this a challenge? And I mentioned earlier there's a little bit of a square peg round hole situation when we try to take these codes that were originally built for humans and adapt them for plants or for facilities intended to grow plants. Well, as we've been hearing several times through this conference, there are differences in creating conditions in a space that are ideal for plant growth. Dehumidification is a huge piece of that, and I'm glad to hear, as Keith mentioned, that there are efforts to create consistent metrics for these dehumidification systems, and maybe we will end up in a place where, kind of like for lighting, I'll go back a couple slides, where we have this generally consistent, it's over there, this generally consistent approach where we say, here's the basic efficiency, be at least this good, and off you go. Maybe with some good metrics on dehumidification, there'll be something along those lines, right? But we're not there yet today, and that's probably fine because there's enormous variability between facilities, between practices, which makes it hard to define the baseline. So we're faced with some challenges and opportunities as we try to define consistent code frameworks in the National Model Code, in the ways jurisdictions might set up their own codes and their licensing regulations, right? Because they can act kind of in the same way. I'll just highlight a couple of these here. One question, of course, what is the baseline, is a pretty important piece. It is not always clear where we're starting from if you're running an incentive program or as a jurisdiction. What is good practice? And Derek and his team at ARI have done some really good work in defining best practices on lighting and HVAC both. There are some places where the code touches these facilities that can lead to unintended consequences or can lead to some challenges. For example, if you've got a facility with a ton of indoor loads, lights, dehumidification, and it's producing a lot of heat, should it be very well insulated, or is that insulation just keeping the heat in and leading to more energy use that you need to deal with? The code may say insulate your envelope. The code may also say put on an air side economizer so you can bring in outside air. But in Oregon, for example, in a few facilities, there are folks that have had to do that, tried to get a variance, didn't get that variance, so they built their facility, they put in the economizers they had to put in. The first thing they did, weld it shut. Yeah, there's an economizer on the roof, but it ain't doing much, right? So that's really an unintended consequence of using a code that was built for human occupancy for plant occupancy. So there are some challenges there. I like to say, in terms of lighting, lumens are for humans. And I think having a PPF, PPE, photosynthetic photonic efficiency, or efficacy, excuse me, provides a good way for us to think about efficiency or efficacy in terms of lighting fixtures, and that's something the people in this room, I think, have a pretty good handle on. In the case of Massachusetts and now Illinois, we've got a different animal going on, which is watts of lighting per square foot of canopy. So now you got these two different approaches that are a bit different and are introducing, I think, something of a challenge, or at least have the ability to. But the main point I want to make is that, broadly speaking, we want to move codes forward because we want these facilities to be built well, both in terms of energy, in terms of greenhouse gas impacts, in terms of getting good facilities for the people who are, procuring them, right? The people, the owners, the operators, and doing their job. These things are not there to save energy, they're there to produce plants, but we want them to do that in a responsible way. So we want good code approaches, we want consistent code approaches so the market knows what to do, but we all have some thinking to do about how do we come up with the right approaches, define the right metrics, whether that's for lighting, various components of HVAC, or some kind of integrated everything, holistic solutions, great. We need to think about how to actually do that for indoor horticulture specifically. So with that, we'll be on to Kyle and then discussion. Thank you.
All right, thanks, Alexi, and I want to thank everyone that joined the codes discussion last night. It was definitely lively, and it's just amazing what happens when you schedule it after happy hour. So thank you all that joined. So I'm going to talk about the statewide utilities team for Title 24, Part 6 of the California Building Code. Okay, so why do codes matter? Indoor cultivation is expanding, and particularly in urban areas, and we're expected to see, 390 gigawatt hours by 2021. So that's a large load, and that's just in California. So, the proposed codes are designed to save growers costs by reducing energy use. So, here we just have a quick example, and looking at if a facility had 244 lights on flower, you're looking at annual cost savings of $83,000. Veg, looking at upwards of $100,000+ annually savings. So California building energy efficiency standards, the energy code is on a 3-year cycle. So right now we're working on what's the 2022 energy code. So it's just barely 2020. So we're a couple years, out, and that won't take effect till January 1, 2023. So it is a regular process in California, and it's on a pretty regular cycle with formalized steps that allow for stakeholder engagement, review of the proposed codes, and all of the documentation that's associated with it. So a little bit different than some of the legislature that's gone through in different states. This is a formal process that's on a rolling basis for the energy code. Okay, so controlled environment horticulture, this proposal will impact newly constructed warehouses in addition to major renovations. So, we're not going to tell a grower that's growing right now, as of January 1, 2023, switch all your lights out. It's going to be someone who's building new or putting on a major addition or a major renovation. We're looking at more than just cannabis, so we are looking at, vegetable crops, microgreens, basil, lettuce, tomatoes, flowers. We have added greenhouse lighting and greenhouse envelope as proposed measures. The greenhouse envelope, I will touch on that because that's a little bit different than some of the other measures. It's actually more of a codes cleanup, because what we've run into is some growers meet the definition of a conditioned space by having mechanical AC, some of those type of sealed greenhouses that we heard about earlier. And they're having a lot of trouble meeting compliance because they're triggering the envelope portion of Title 24. So in that envelope portion, there's nothing specific to greenhouses, so they're having to meet basically like a warehouse or something like that envelope. So as you know, that's really not feasible with regular greenhouse materials. So we want to make that so it is, it's possible to comply with. Okay, so the statewide utility codes and standards team, so they actively support the California Energy Commission in developing these codes. This is a congregation of all the IOUs in California, and they're really trying to produce energy savings through feasible, enforceable, cost-effective, and non-proprietary codes. So those are really important. We don't want to propose something that's not cost-effective or that is overly burdensome for the grower. Okay, so the overall goal here is to provide the information needed so that the Energy Commission can make an informed decision on how to set a code. So that's energy and demand impacts, cost effectiveness, technical feasibility, market impacts, crop quality and productivity. We're getting out of the human space, so it is important to think of, okay, this is a process, and we want to make sure that anything that we propose isn't going to hurt that process. So suggested code language, compliance and enforcement, how are we going to make sure that what we're recommending is actually done and done properly? Yeah. Okay, so here's some key dates for the controlled environment horticulture measure, and I do have some flyers that you guys can take after, so I'll have those out after this. So April 16th is our next public stakeholder meeting. You'll see at the end of this, there's a link to how to sign up for that and register. So I hope everyone will join. And definitely give your feedback. Draft case report will be published. The case report is really our recommendations and documentation of what went into all this research. So that will be published May 15th on title24stakeholders.com. And that's a really good resource for just anything as far as updates on the code process. And you can go and click and look at controlled environment horticulture, and it'll give you an email, mailing list specific to that measure. So any major things that happen to that measure, you'll get an email. Final case report, and then after we do that part, it goes to the Energy Commission, and they have a series of public stakeholder meetings, and then next year in April 2021 is when the actual adoption of the standards will happen, and then January 1, 2023 is the effective date. Okay, so looking at the particular submeasures that we have, and I know we're running low on time, so I'm going to go a little bit quick, but leave time for questions after. We're looking at horticulture minimum lighting efficacy, dehumidification efficiency, environmental and irrigation controls, circulation fan minimum performance, and then the greenhouse lighting and greenhouse envelope. Okay, so looking at horticultural lighting efficacy, we are looking at using a product efficacy, so PPE, and specifying a certain micromoles per joule. And one, kind of some things that came out of last night were, helpful in kind of modifying this a little bit. So there was a suggestion for doing a certain percentage of the wattage to leave some exemptions for, particular purpose lights, like for propagation or other things like that. So that will likely be built in. And yeah, so then we also have kind of some typical product types there. And then let's see. Okay, here's some existing codes that exist. We've got Massachusetts, Illinois, Denver and Washington State, Massachusetts and Illinois going with a lighting power density, Denver and Washington State going with a PPE similar to what IECC is doing. So, and the nice thing about PPE is that it does, there's not as many issues with how are you going to define canopy, the loopholes that growers can have to kind of, space their plants out and do things that we really aren't trying to get them to do with the code, but it's ways they can work around it. For dehumidification, there was some really good discussion on this last night too. We've been wanting to establish a minimum moisture removal efficiency, but based on where the industry's at right now and what's available for standards, this may not be feasible this code cycle. But Colorado actually just put through some standards for dehumidification equipment that would be a good start right now. So it specifies several different acceptable methods of dehumidification. So we'll be modifying this, and here's a couple of current standards. Santa Rosa having a ventilation rate requirement, Illinois with their HVAC requirement. Circulation fan performance, so this is to do a minimum CFM per watt. And this is one that, as Nadia pointed out, is definitely a lower priority as far as energy savings. But the idea is to kind of create a minimum floor. So, and greenhouse lighting efficacy, very similar to the warehouse, just in greenhouse facilities as well. The other measures, dehumidification, controls, circulation fans, will not be applicable to greenhouses, just indoor facilities. So that's an important distinction to make. And then environmental and irrigation controls. A lot of facilities might have most or all of these. So this is really, again, trying to set a minimum floor, make sure all newly constructed facilities have, temperature, humidity controls, irrigation controls. Yeah, and we want everyone here to get involved. So sign up for the email updates, the second public stakeholder meeting. Thank you to everyone that already has given your feedback. Last night was very productive, and I really thank everyone for staying that extra hour because I was happy to get people for 1 hour, so 2 was great. And you can send comments on code language to info@Title24 stakeholders and copy myself on there. Great. All right, thank you.
Thanks, Kyle. Thanks so much, Kyle. So we have a few minutes for questions. If anybody has any questions for our panel.
Great presentations, thank you. I noticed a little bit of slippage in language over the course of this event, and so controlled environment horticulture versus controlled environment agriculture. I don't know if those are small details or maybe they're big details. Maybe you could comment on that. And also to Keith, the question on, are we using the right terminology when we say HVAC in controlled environment horticulture, agriculture?
I'll take the second one first. Yes, we have to use the HVAC because as we look at what these standards are going to be, it's going to be the heating, cooling, ventilation. Unfortunately, there's not the D part of that, but it's implied within the industry. So I think we don't want to remove it. We want to keep it all in because it covers all those segments.
I think the microphone's on.
Yeah, and I can address the first part. So controlled environment horticulture, we had a couple iterations of what the name should be. There was CEA is another acronym that the Energy Commission uses frequently. So there was a conflict there, and it was a definition that seemed to really narrow in on the facilities we were looking at. So I do understand that there's a little bit of industry terminology differences there, but there were some specific reasons we had to go with that.
Yeah.
And that was part of it.
He said technically agriculture includes animals, and that was one of the reasons on the national model code level that IECC 2021 proposal is indoor horticulture lights, not just agriculture. It's specifically for plant applications, although it also says it a little further down. But yeah.
Kyle, is floriculture in CEH? Is there flower production in California? Is it covered under horticulture? And that double-ended HPS lamp efficacy that shows up in the DOE 2017 report, I don't know if that's bare lamp, but it's certainly not fixture efficacy. The highest I've ever seen is like 1.72 when I tested it. So it seems sort of like an outlier compared to the others. Sure.
Yeah, so thanks. To address the first part, as far as floriculture, yes, so all crops are considered, for indoor and for greenhouse. I imagine the greenhouses will have the higher, percentage of the floriculture. So that will be, just the lighting measure in the envelope. And the envelope is only for conditioned greenhouses. So the definition of conditioned in Title 24, Part 6 is 5 BTUs per hour per square foot of mechanical cooling. So not evaporative cooling, but like AC, and then 10 BTUs per hour per square foot of heating.
So I was wondering if we're, since we're expanding Title 24 and we're expanding building codes to nominally cover horticulture, are we now considering that all greenhouses are now going to be real buildings with real codes about how they're built, and that we're going to be going down that path as well? And as a kind of follow-up question to that, are we also looking at other types of industrial facilities like car plants, and are we going to have a special code for car plants and a special code for paint factories and a special code for all of these other kinds of buildings that are really purpose-built and that might not have that same level of customer ignorance when they get sold or when they get rented?
Sure, that's a great question. So as far as, I'll start with, the different processes. So there are some processes that are already covered within Title 24, Part 6, refrigerated warehouses, compressed air, parking lot lighting, and there's a few others. So that may grow, but this isn't the first time that that's been done. It's been done since 2008. So there are several other processes that are involved in that. As far as, how deep the Energy Commission will dive into greenhouses in subsequent code cycles, I can't necessarily comment on that. As far as what we're looking at now with greenhouse lighting and the envelope, that's as far as we will go in this code cycle. I just can't comment any further on that.
Time for one last quick question. I brought it up the other night, but how would you see the policing of something under the DLC requirement being, anything, let's say it's at 1.6, anything between 1.6 and the DLC minimum, because there's no independent third party looking at that? And yeah, if you can just speak to any preliminary thoughts on that.
Yeah, that's a great question, Brady. So this is, something we're currently considering how to deal with that. One possible solution is to characterize the existing incumbent technologies that fall, below that threshold and aren't on the DLC qualified products list. So that could be one, and then adding a table to the building code so that there is accepted, PPE ratings for those particular technologies. There is some complexity to that because you're going to have to look at, some different variations of reflectors and Of course, single-ended versus double-ended, I mean, I see those as almost a different fixture, even though they can both be high-pressure sodium, and then also making sure those are well vetted with the industry. So, making sure that those are industry-accepted numbers. So that's one possible method. Independent testing is another that's got its own stickiness to it. So, a couple possible solutions.
All right,
But
great.
there is at least a standard to test to at this point.
All right, great. Thank you. Let's give a hand to our panel.